Hi, I'm Chris with Sanderson Test Prep, and in this video we're taking a look at another challenging indefinite integral. So here we see it's the integral of dx over x times the square root of 16x squared minus 16. And this is pretty challenging because they add some numbers inside that square root, and it sometimes makes it difficult to identify what the appropriate derivative is as it relates to our trig functions here to recognize it. So if you see that two values inside of a root share the same coefficients, and you can oftentimes factor that out, and that can make the question shape up nicely to look a little bit more like some of those derivatives of certain kinds of trig functions or inverse trig functions that you might have already memorized. And if you haven't yet memorized those, then that's something that, if you're tackling a problem like this, means that that's something that you should be memorizing, because those are going to come up for these kinds of questions. But first things first, to make it look right, let's see if we could factor out the 16. And so here this is the equivalent of saying the integral of dx over x times the square root of 16 times x squared minus 1 when we factor it out. And then when you pull it outside the root, so we can pull it outside the root as a 4. So we'd have dx over 4x times root x squared minus 1. And then to simplify things even further, we can put it out front of our integral entirely. And we're left with something that's going to look like this. And then here's where memorizing those derivatives of inverse trig functions is going to come into play, because on this, hopefully if we look at this, we can recognize that what we see here in this integral looks a little bit like the derivative of our inverse secant or our arcsecant function. And so if we're able to recognize that, then that's going to help inform for us what the process is going to look like when we go to solve and actually come up with the correct answer here. So since we're dealing with an inverse secant, that means that we want to set x equal to a secant value for the substitution part of this. So here, and I'll just write this off to the side, so we're going to do x equals secant theta. And then when we go to take the derivative of that, that means dx would equal secant theta tangent theta. And now we can use that information to do a little bit of substitution here and see how this is going to play out. So this will be 1/4 times the integral of, so in our numerator for dx, we know dx is secant theta tan theta, so let's write that in. And oops, I forgot to write in my d theta. That was a little bit sloppy. Let me sneak that in there. D theta. Kind of squeeze it in towards the edge, but I'll write it in the integral up here. So that's going to be our numerator. And then in our denominator, we'll have secant theta for x. And then inside the root, so we have secant squared theta minus 1. And again, if we don't know our trig identities comfortably enough, then it might just be something that we need to refresh to make sure that we can recognize how we can simplify these kinds of problems as fully and easily as possible. But secant squared theta minus 1 is going to be equal to tan squared theta. And I'll write it out in 2 steps just to make sure we're comfortable with everything. But we have secant theta tan theta d theta in our numerator still. And then we have secant theta times the square root of tangent squared. And the square root of a squared value is just going to be, in this case, it's just going to be tangent theta. So look how nicely this is going to simplify itself for us here in this step. We've got secant theta tan theta d theta in our numerator. And we've got secant theta tan theta in our denominator. So a huge chunk of this integral that might look quite complex at first glance all of a sudden simplifies in a very friendly way for us here. So now we're left with 1/4 times the integral of just d theta. And the integral of d theta, you can think of it as if it's 1 d theta, but the integral of 1 d theta is just going to be theta. So this would be, when we go to integrate, we would have 1/4 times, and then this integral would just be theta, and then because it's indefinite, it would be plus c. But now in place of theta, so if we need to convert back into our x term, remember the substitution that we used back up here. So here, let's keep these values. I'm going to copy those and just paste them down here so we can see them beside this. So we know x is secant theta, which means if we're solving for theta, theta would be the inverse secant of x. So this would be 1/4 times our inverse secant or arcsecant of x plus whatever that constant is that we attach on to the end of our integral. So that's the way that this integral can be solved. It does require having a really strong understanding of both trig identities and derivatives of your trig and inverse trig functions. So if that content knowledge is a little bit weak, then that's something we want to brush up on to be able to see a question like this in the right way, so that we can take something that looks overtly complicated at first glance and help simplify it as much as possible. For more, please check out our other videos, and thanks for watching.